So in this presentation, we'll quickly go over what Kata Containers is, and then go over a few things that have changed in the last 1 year. I think I presented Kata here around a year back. So we'll go over some of the changes that have happened. And after that, we'll do a few live demos of the new features that we have in Kata. So for people who are familiar with containers, containers today, which use the run C, achieve separation between containers using kernel provided software separation mechanisms. This is C groups, namespaces, your capabilities, mandatory access control, etc. So with Kata containers, what we have done is you can launch containers, but now these containers are isolated with the combination of both software separation mechanisms as well as using VTX in the case of Intel, or in case of ARM, the equivalent separation mechanisms provided in hardware. So now containers are separated from one another using mechanisms which are implemented in hardware. So that gives you a stronger boundary between containers. So what you get with something like Kata containers is you get almost the same speed as software-based containers. At the same time, you get the separation that you get from hardware. And the key thing to keep in mind is with something like Kata containers, you still interact with them as containers. You do not interact with them as virtual machines. Even though they use virtual machine technology to separate containers, from a user point of view, developer or a deployment point of view, they act and behave just like containers. So as I mentioned before, with Kata containers, you get both the software-based isolation as well as hardware-based isolation. So very quickly, what is Kata containers? Kata containers implements the OCI specification. So what it means is, just like run C, it is an OCI compliant container runtime. That means with the OCI compliant runtime, we can support Kubernetes, Docker, and for that matter, even we can run with OpenStack Zone. And where can you run Kata today? We provide packages for almost all the common distros, as well as we provide a container package binaries using something called Kata deploy. So if you don't have packages for your distro, you can deploy Kata containers on your machine using our binaries packaged in containers. They run on any hardware that supports virtualization. This includes hardware from Intel, AMD, ARM, and IBM. And also you can run it in the cloud. You can run it on cloud providers that offer bare metal offerings, as well as at this point of time, multiple CSPs offer support for nested virtualization. So you can run it in the cloud too, even when you're not running bare metal in the cloud. So we will, as part of this, we'll do a very quick demo showing how Kata containers works seamlessly with Docker. Okay, so now I'm just quickly going to cover what has changed in the last 1 year. When we first started with Kata containers, we used KVM and QEMU to implement Kata containers. Over time, we actually did a slimmed down QEMU, which is called QEMU Lite, and then we built our own lightweight version of QEMU called Numium. After that, there was the Firecracker VMM released by AWS that still used KVM but was a Rust-based, very lightweight and very thin VMM. So Kata Containers over the last